Studies Section 15. Annuities and Sinking Funds. Introduction. An annuity is a series of equal payments made at specified intervals. Interest is compounded on each of these payments. Annual payments can be made at the beginning or the end of the specified intervals. If they are made at the beginning of the period, the annuity is called an annuity due, and if the payment is made at the end of the period, it is called an ordinary annuity. Annuities are commonly encountered in business and accounting situations, and the operation of sinking fund is based on the principle of annuities. In this study section, we assume ordinary annuity. Objectives. At the end of this study section, you should be able to 1. Calculate the future value and the present value of annuity using different methods, and 2. Apply the annuity methods in solving sinking fund problems. Pretest. 1. What is the relationship between annuity and sinking fund? 2. Explain the differences between the present value of annuity and the future value of annuity. 3. List and explain the different methods of solving annuity problems. Content. A. Future value of an annuity. The future value of an annuity is the sum of all the periodic payments plus the interest that has accumulated on them. In general, we can solve a variety of problems involving the value of an annuity by using the formula below. Future value of an annuity, FV, is equal to Take 2. Content. A. Future value of an annuity. The future value of an annuity is the sum of all the periodic payments plus the interest that has accumulated on them. In general, we can solve a variety of problems involving the value of an annuity by using the formula below. Future value of an annuity, FV, is equal to factor times annuity payment. Example 1. What is the future value of a deposit of 1,000 naira at the end of each of the next 4 years in a saving account that pays 10% interest compounded annuity? We can obtain the solution to this problem in different ways as shown in sections that follow. B. Calculating future value of annuity from accumulated balance. Using the accumulated balance at the end of each year, the future value can be calculated as follows. Year 1. Deposit 1,000. Year 2. Balance brought forward 1,000. Interest on year 1 balance 10% of 1,000. 100 naira. Deposit 1,000. Year 3. Balance brought forward 2,100. Interest on year 2 balance 10% of 2,100. 210. Deposit 1,000. Year 4. Balance brought forward 3,310. Interest on year 3 balance 10% of 3,310. 331. Deposit 1,000. Future value 4,641 naira. C. Calculating future value of annuity from each installment. Future value of the first installment in naira. Deposit 1,000. First interest 100 is equal to 1,100. Second interest 110, making 1,210. Third interest 121. Future value of the first installment 1,331. Using the same format, the future value of the second installment is 1,210 naira. The third installment will have a future of 1,100. The last installment will have no installment since it is paid at the end of the year. The future value of the annuity is calculated as follows. In naira, future value of first payment 1,331. Future value of second payment 1,210. Future value of third payment 1,100. Future value of fourth payment 1,000. Future value of the annuity 4,641. D. Using table of future value of annuity, period 2%, 3%, 9%, 10%. 1. 1.000 2%. 1.000 3%. 1.000 9%. 1.000 10%. 2. 2.020 2%. 2.030 3%. 2.090 9%. 2.100 10%. 3. 3.060 2%. 3.091 3%. 3.278 9%. 3.310 10%. 4. 4.122 2%. 4.184 3%. 4.573 9%. 4.641 10%. 5. 5.204 2%. 5.309 3%. 5.985 9%. 6.105 10%. From the above table, the annuity factor of an ordinary annuity over 4 years at 10% is 4.641. You can now calculate the future value of the annuity as follows. Future value of annuity is equal to 4.641. FV factor times 1,000 naira annuity is equal to 4,641 naira. E. Using table of future value of a single amount. Periods 2%, 3%, 9%, 10%. 1. 1.020 2%. 3. Take 2. 1. 1.020 2%. 1.030 3%. 1.090 9%. 1.100 10%. 2. 1.040 2%. 1.061 3%. 1.188 9%. 1.210 10%. 3. 1.061 2%. 1.093 3%. 1.295 9%. 1.331, 10%. 4. 1.082, 2%. 1.126, 3%. 1.412, 9%. 1.464, 10%. 5. 1.104, 2%. 1.159, 3%. 1.539, 9%. 1.611, 10%. Using the logic of Section C, you will discover that the first installment will earn interest 3 times. The second installment will earn interest twice, while the third installment will earn interest only once. Future value of the first payment is equal to 1.331 times 1,000 is equal to 1,331 naira. Future value of the second payment is equal to 1.210 times 1,000 is equal to 1,210 naira. Future value of the third payment is equal to 1.100 times 1,000 is equal to 1,100 naira. Future value of the last payment is equal to 1,000 naira. Future value of the annuity is equal to 1,331 naira plus 1,201 naira plus 1,100 naira plus 1,000 naira is equal to 4,641 naira. F. Using formula of future value of annuity. You can also use formula to calculate the factor instead of using actual tables. FV annuity is equal to A parenthesis open bracket open 1 plus R bracket closed raised to power n minus 1 parenthesis closed over R is equal to bracket open 1 plus R bracket closed raised to power n minus 1 over R factor times A annuity, where A is the annuity, the regular payment, R is equal to interest rate, N is equal to number of years. For our example, A is equal to 1,000 naira, N is equal to 4 years, R is equal to 10%, which is equal to 0.1. FV annuity is equal to 1 plus 0.1 raised to power 4 minus 1 over 0.1 times 1,000 naira is equal to 1.1 raised to power 4 minus 1 over 0.1 times 1,000 naira is equal to 1.4641 minus 1 over 0.1 times 1,000 naira is equal to 0.4641 over 0.1 times 1,000 naira is equal to 4.641 times 1,000 naira is equal to 4,641 naira. G. Using formula of future value of a single amount. You can use formula to calculate the future value of a single amount in ordinary annuity. FV of a single amount is equal to A bracket open 1 plus R bracket closed raised to power n is equal to bracket open 1 plus R bracket closed raised to power n times A. Recall that for our example, n will be 3 for the first installment, 2 for the second installment, and 1 for the third installment. FV of the first payment is equal to 1,000 naira into bracket 1.3 raised to power 3 is equal to 1,000 naira times 1.331 is equal to 1,000 331 naira. FV of the second payment is equal to 1000 naira into bracket 1.1 raised to power 2 is equal to 1000 naira times 1.21 is equal to 1210 naira. FV of the third payment is equal to 1000 naira into bracket 1.1 is equal to 1100 naira. FV of the cost payment is equal to 1000 naira. FV of the annuity is equal to 1331 naira plus 1210 naira plus 1100 naira plus 1000 naira is equal to 4641 naira. H. Present value of an annuity. This is the value today of a series of equal payments or receipts to be made or received on specified future date. We can also solve a number of problems involving the present value of an annuity by using the equation below. Present value of an annuity is equal to PV factor times amount of the annuity, where PV factor of a single amount is equal to 1 over 1 plus R into bracket raised to power n. Example. Assume that you were offered an investment that paid 1000 naira a year at the end of each of the next 4 years. What is the value of the investment today if you desire a return of 10%? Again, we will obtain the solution to this problem in different ways. I. Calculating present value of annuity from accumulated balance. Year 4. Receipt 1000 naira. Discount factor 1.1. Year 3. PV in year 4 receipt 909 naira 09 kobo. I. Calculating present value of annuity from accumulated balance. Year 4. Receipt 1000 naira. Discount factor 1.1. Year 3. PV in year 4 receipt 909 naira 09 kobo. Year 3 receipt 1000 naira. Total 1909 naira 09 kobo. Discount factor 1.1. Year 2. PV of balance from year 3 1735 naira 54 kobo. Year 2 receipt 1000 naira. Total 2735 naira 54 kobo. Discount factor 1.1. Year 1. PV of balance from year 2 2456 naira 64 kobo. Year 1 receipt 1000 naira. Total 3486 naira 85 kobo. Discount factor 1.1. Year 0. Present value now 3169 naira 86 kobo. Therefore, the present value is 3170 naira to the nearest whole number. J. Calculating future value of annuity from each installment. PV of year 4 receipt is equal to 1000 over 1.1 raised to power 4 is equal to 1000 over 1.4641 is equal to 683 naira 01 kobo. PV of year 3 received is equal to 1000 naira over 1.1 raised to power 3 is equal to 1000 naira over 1.331 is equal to 751 naira 31 kobo. PV of year 2 received is equal to 1000 naira over 1.1 raised to power 2 is equal to 1000 naira over 1.21 is equal to 826 naira 45 kobo. PV of year 1 received is equal to 1000 naira over 1.1 raised to power 1 is equal to 1000 naira over 1.1 is equal to 909 naira 09 kobo. PV of annuity is equal to 683 naira 01 kobo plus 72 plus 751 naira 31 kobo plus 826 naira 45 kobo plus 909 naira 09 kobo is equal to 3,169 naira 86 kobo. It's equivalent to 3,170 naira. K. Using table of present value of amount, period, 2%, 3%, 9%, 10%. Period 1, 0.980, 2%, 0.971, 3%, 0.917, 9%, 0.909, 10%. Period 2, 0.961, 2%, 0.943, 3%, 0.842, 9%, 0.826, 10%. Period 3, 0.942, 2%, 0.915, 3%, 0.772, 9%, 0.751, 10%. Period 4, 0.924, 2%, 0.888, 3%, 0.708, 9%, 0.683, 10%. Period 5, 0.906, 2%, 0.863, 3%, 0.650, 9%, 0.621, 10%. PV of 1000 naira received at the end of year 1 is equal to 0.909 times 1000 naira is equal to 909 naira. PV of 1000 naira received at the end of year 2 is equal to 0.826 times 1000 naira is equal to 826 naira. PV of 1000 naira received at the end of year 3 is equal to 0.751 times 1000 naira is equal to 751 naira. PV of 1000 naira received at the end of year 4 is equal to 0.683 times 1000 naira is equal to 683 naira. PV of the annuity is equal to 909 naira plus 826 naira plus 751 naira plus 683 naira is equal to 3,169 naira, approximately 3,170 naira. L. Using table of present value of annuity. Periods 2%, 3%, 9%, 10%. Period 1, 0.980, 2%, 0.971, 3%, 0.917, 9%, 0.909, 10%. Period 2, 1.942, 2%, 1.913, 3%, 1.759, 9%, 1.736, 10%. Period 3, 2.884, 2%, 2.829, 3%, 2.531, 9%, 2.487, 10%. Period 4, 3.808, 2%, 3.717, 3%, 3.240, 9%, 3.170, 10%. Period 5, 4.713, 2%, 4.580, 3%, 3.890, 9%, 3.791, 10%. PV of the annuity is equal to 3.170 times 1,000 naira is equal to 3,170 naira. M. Using formula of PV of annuity. PV of annuity is equal to A, parenthesis open, 1 minus bracket open, 1 plus R, bracket closed, raised to power minus N, parenthesis closed, over R is equal to 1 minus bracket open, 1 plus R, bracket closed, raised to power minus N, over R times A, where all variables are as we defined them before for our example. PV of annuity is equal to 1 minus bracket open, 1 plus 0.1, bracket closed, raised to power minus 4 over 0.1 times 1,000 naira is equal to 1 minus bracket open, 1.1, bracket closed, raised to power minus 4 over 0.1 times 1,000 naira is equal to 1 minus 0.683 over 0.1 times 1,000 naira is equal to 0.31699 over 0.1 times 1,000 naira is equal to 3.1699 times 1,000 naira is equal to 3,169 naira 9 kobo, approximately 3,170 naira. N. Sinking fund. Sinking funds is a special fund that is established for a specific purpose. For example, to make future purchase of fixed assets or to repay long-term debts. It is a collection of cash or other marketable assets that is set apart from the firm's other assets and is used for a specified purpose. The fund is generally under the control of a trustee or agent who is independent of the enterprise that established the fund. The issuing company makes periodic payments to its sinking funds. These monies are then invested by the trustee in a sinking investment. To accumulate a sinking fund, you need to transfer an equal amount to the sinking fund account. Simultaneously, you transfer an equal amount to the trustee annually. O. Relationship between sinking funds and annuities. In a sinking fund, you invest an equal amount annually. The investment earns compound interest at a specific rate. You expect the investment and the compounded interest to accumulate to a specific amount. You will agree that the calculation of the amount that a sinking fund will accumulate to in future is a future value. You can calculate this future value in the same way you calculate the future value of annuity as follows. SF is equal to A, parenthesis open, bracket open, 1 plus R, bracket closed, raised to power N minus 1, parenthesis closed, over R is equal to bracket open, 1 plus R, bracket closed, raised to power N minus 1 over R times A, where SF is equal to amount you want to accumulate from the sinking funds, A is equal to annual investments, B is equal to numbers of years, R is equal to interest rate. Example: Fleming Limited issued 100,000 naira 8% debenture in 2000 with condition that a sinking fund be set up for its redemption 5 years later. The sum to be set aside every year should be such that when invested annually at a compound interest rate of 12% per annum will amount to 120,000 at the due date of redemption. You are required to determine the appropriate amount to be transferred to sinking fund account annually. Solution: SF is equal to bracket open 1 plus R bracket closed raised to power n minus 1 over R times A. That is 120,000 is equal to 1 plus 0.12 into bracket raised to power 5 minus 1 over 0.12 times A. 120,000 is equal to 1.7623 minus 1 over 0.12 times A. 120,000 is equal to 6.3525 times A. A is equal to 120,000 over 6.3525 is equal to 18,890. Therefore, Fleming Limited will transfer 18,890 to sinking funds account annually. Summary: an annuity is a series of equal payments made at specified intervals. The future value of an annuity is the sum of all the periodic payments plus the interest that has accumulated on them. This future value can be calculated on accumulated balance on each installment by using table of future value or by using formula. Present value of an annuity, on the other hand, is the value today of equal payments or receipt to be made or received on specified future date. Like the future value, you can also calculate present value in different ways. The logic of calculating annuity is used in sinking fund calculation. Sinking fund involve invest of equal amount annually. This is the end of study section 15 and the end of Echo 312. Thanks for listening.